I'm going to explain today the transconductance model. Conductance means what? Current or voltage. And it is transconductance mean. Just wait. Let me take this parameter HFE upon HIA. HFE is the forward current ratio. HIA is the input impedance for common emitter, configuration. Because here the C small e. This is for common emitter. Forward current ratio for common emitter is IC over IP. And input impedance is VBE upon IP. IP cancels out. And HFE upon HIE becomes IC upon VBE. So this is current over voltage. Current over voltage is current of the output port and voltage the input port. That's why I call trans. So this is transconductance. And it's denoted by GM, sometimes called as a mutual conductance also. So GM is IC over VBE and it is HFE upon HIE. This is a very important relation. Okay. So let me draw the circuit like the ammeter base collector, the three currents, ammeter current, base current and collector currents. Ammeter current is the outward, the other currents will be inward, base current and collector current. You always remember. If IE is inward, then the other two will be outward. If IE is outward, then other two will be inward. IE is a function of VBE and IE increases exponentially with VBE. If you increase VBE, base ammeter voltage, IE increases exponentially. So the exact expression is the leakage current ICO exponential of VBE upon KT, KTE upon E. Because the nature of KT upon E is that of the voltage. So current gain in common base configuration is denoted by alpha, and alpha is what in common base? That is the collector current over the emitter current with minus sign. You know why minus sign is here? Because the attraction of IC and IE, they are opposite in a way that if IE is outward, IC will be the inward. So here IC becomes minus alpha times IE. Substituting this IE in the above expression. So just simplifying. ICO is the leakage current, Now, in order to find the GM, and GM is defined as, which is the transfer conductance, curly IC or curly VBE. So we are differentiating it with respect to VBE. Okay. So let's do the differentiation with respect to VBE. First of all, the whole factor as it is into the differentiation of the power of exponential. That becomes then E upon KT. So the bracket term is IC. So this is the result, that GM is equals to IC E upon KT. E is the electron charge and K is the Boltzmann constant. Substituting the electronic charge and Boltzmann constant, that comes out 11600 upon T into IC. That's because conductance, it is mho. If we set the temperature 300 Kelvin, then, and if we take IC in milliampere, then means substituting IC directly in milliampere in the expression, then it becomes IC over 26. You have to substitute IC here in milliampere only. It becomes mho. So this is the expression of the GM. So GM is directly proportional to the correct current more the transconductance. This is theoretical value. The actual value of GM is slightly less. Why less? This is a task for you. You think over it. I'm going to explain today